IBESS, Soil and Terrestrial Food Production Part 4, is the first of two movies in this series that examine soil management strategies. The significant ideas are human activities may reduce soil fertility and increase soil erosion, and secondly, soil conservation strategies exist and may be used to preserve soil fertility and reduce soil erosion. Here is the first of two slides that outline the available movies in the Soil and Terrestrial Food Production unit. Use this outline to find the movie you need for review. This movie is focused here. Here is the second of two slides that outline the available movies in the Soil and Terrestrial Food Production unit. Use this outline to find the movie you need for review. Here are the two IB syllabus statements that drive this movie and the next one. Outline soil conservation measures, including cultivation techniques, terracing, contour plowing, and strip cultivation, wind reduction techniques, windbreaks and shelter belts, soil conditioners, organic materials such as manure, and lime, and lastly, a soil conservation measure of avoiding the use of marginal land. Secondly, evaluate soil management strategies in a named commercial farming system and in a named subsistence farming system. Here is a list of soil conservation measures, and in this movie I will explain terracing, contour plowing along with strip cultivation, windbreaks and shelter belts, and soil conditioners including fertilizers, lime, which is calcium carbonate, and manure, an organic conditioner. Now in part 5 of this series, the next movie, I will explain the technique of avoiding the use of marginal land. I will also go on to explain some till techniques, use of cover crops, crop rotation, and reforestation. Now, I will work to evaluate each technique, providing both strengths and weaknesses. And with each image I present, I want you to evaluate whether the soil conservation technique better serves a commercial farming system or a subsistence farming system. So let's start with terracing. Terracing is a dramatic manipulation of the land by creating large steps, alternating flat ground with steep edges. And you can see the terracing in this image. Terracing reduces the slope over which water would flow, thus reducing erosion. Terracing also provides flat ground on which crops can be grown. Terracing provides flat ground on which to grow crops, and the flat tops of each step can hold water. The flat steps hold water rather than allowing water to run off quickly. In this way, terracing reduces erosion. Terracing requires a huge input of human labor. To terrace the land takes a lot of work. Terraces in rural areas are beautiful, but it's important for you to recognize how manipulated the terraced land has become. Terraced land is highly manipulated land. The original ecosystem, whatever it was, is gone. Biodiversity is less. Terracing would be a soil conservation more likely to be found in less economically developed countries, used more by subsistence farmers than by commercial farmers. So, could you list the strengths and weaknesses of terracing? Could you evaluate terracing as a soil conservation measure? I've stated the strengths and weaknesses in the past 4 slides. Have you been taking some notes? As I mentioned, terracing is more likely to be used as a soil conservation measure in less economically developed countries, LEDCs. And it's employed as a cultivation technique more for subsistence farm systems than industrial commercial farm systems. Here are the strengths of terracing as a cultivation technique. Stop the movie now, take some notes. I'll let you study this slide on your own. Here are the weaknesses of terracing as a cultivation technique. Stop the movie now, take some notes. I'll let you study this slide on your own. Let's move on to contour plowing. Contour plowing is similar to terracing, but contour plowing is practiced on less steep land. The concept is to plow following the contour of the land to inhibit water from running straight downhill, carrying soil with it. Contour plowing also serves to reduce erosion. Here is a nice photograph of contour plowing. You can see how the rows follow the contour of the land, or one could say the rows are perpendicular to the slope. Contour plowing inhibits water from running directly downhill. Contour plowing reduces erosion. A soil conservation measure, a soil cultivation technique practiced in combination with contour plowing, is strip cropping, or as I've noted here, strip cultivation. Strip cropping is defined as the growing of different crops in alternating strips following the contour of the land. This increases the diversity of the farm, brings different plants with different needs to the soil, all the while following the contour of the land to reduce erosion. Here is a photograph taken from the air of contour plowing and strip cultivation together. The cultivation follows the contour of the land in addition to growing different crops in alternating strips or rows. The contour plowing reduces erosion, and the different species increases the diversity of the farm. Strip cultivation reduces soil nutrient depletion. Let me say that again. Strip cultivation reduces soil nutrient depletion. Nutrient depletion occurs in monocultures. Strip cultivation involves a few different crops, increasing the diversity and nutrient enrichment of the soil. Here is an annotated photograph that nicely shows the strip cultivation, and notice that the land has been plowed following the contours of the land. One disadvantage of contour plowing and strip cultivation is the planting and harvesting can take more time because the crops are not uniformly planted across the landscape. Here is another image from the air of contour plowing and strip cultivation. While erosion is reduced and the farm has greater biodiversity, the planting and harvesting take more time, and the farm profits depend on the species planted. Can you evaluate contour plowing and strip cultivation? One thing to note is that the techniques of contour plowing and strip cultivation can be employed by commercial farm systems or subsistence farm systems. Here are the strengths and weaknesses of contour plowing and strip cultivation. You can stop the movie now and study this slide on your own. Remember, I'm following this outline and I'm about to talk about windbreaks and shelter belts. Windbreaks are rows of trees serving to reduce the speed of the wind across the land. The distance of open land, land without physical interruptions, is called the reach, and the greater the reach, the greater the wind speed. If the open areas can be divided by rows of trees, the reach of the wind is less, resulting in lower wind speeds. Lower wind speeds results in less erosion of the soil. Here is a photograph of a windbreak in New Zealand. This is a photo that I took. Windbreaks reduce the reach of the wind, reducing wind speeds, thus reducing erosion of the soil. Windbreaks must be planted perpendicular to the prevailing flow of the wind, which may or may not serve the planting of crops. As well, windbreaks reduce the amount of land on which crops could be planted. Here's a diagram that shows how windbreaks influence wind speeds. In this diagram, the wind is blowing from right to left, and as the wind approaches the windbreak, it's moving at nearly 30 miles per hour. Now, the windbreak slows the wind, and it lifts the wind to a slightly higher altitude. The region immediately behind the windbreak is experiencing very low wind speeds, down to about 8 miles per hour. In this diagram, it takes almost 800 meters for winds to pick up to their original speed of 30 miles per hour prior to the windbreak. Now, shelter belt is another name for a windbreak. However, the term shelter belt is often used to indicate that there are multiple crops on the field, as you can see in this photograph, where fruit trees serving to reduce wind speeds, reducing erosion, but also serving to protect other crop species seen here in the middle of the photograph. Not only is soil erosion reduced by the windbreak, but different crops extract different nutrients, so the nutrient loss in the soil is not so severe. Here are two photographs of shelter belts. The top photograph appears to be more of a traditional windbreak, although the rows of trees could be providing a fruit crop or timber, wood. The lower photograph clearly shows rows of trees on either side of a second crop. It seems clear from the cultivation in the photo that there are at least two crops, and no doubt the trees serve to reduce soil erosion by the wind. Can you evaluate windbreaks and shelter belts? Remember, both soil conservation techniques would be employed by commercial farm systems and subsistence farm systems. Here is a slide with the evaluation of windbreaks and shelter belts. You can stop the movie now and study this slide on your own. So far, we've looked at terracing, contour plowing, and windbreaks. Up next, we'll take a look at soil conditioners. Soil conditioners are substances that people would add to the soil to restore lost nutrients or add to the soil for the purposes of enhancing the soil. Fertilizers are industrially produced chemicals that farmers buy to restore nutrients to the soil. Nitrogen, nitrates, would be the most important component of fertilizers, and it is applied in powder or liquid form. More than 100 million tons of nitrogen fertilizers, nitrates primarily, would be applied to farm fields worldwide every single year. Arguably, too much fertilizer is used worldwide, but it does boost NPP, so farmers are tempted to overuse it. Excess fertilizer runs off the land and into the rivers, lakes, and oceans. Fertilizer runoff is a pollution problem and creates eutrophicated bodies of water. We've already studied eutrophication earlier in this course. Eutrophication is a problem of excess nutrients, typically from runoff, agricultural runoff that carries fertilizers, or it could be from sewage. The excess nutrient load causes blooms of algae, followed by a cascade of ecological changes that degrade the system. We've already studied eutrophication, and if you're not sure of this complicated pollution problem, you need to go back and review what we studied in Water and Aquatic Food Production, Part 12. Lime, calcium carbonate, is used to raise the pH of the soil. Increasing the pH makes the soil less acidic, enhancing the growth conditions for plants. Soil pH influences the availability of soil nutrients. An acidic soil, low pH, is not ideal for net primary production, so farmers increase soil pH with lime to promote net primary productivity. Lime, like industrially produced fertilizers, is expensive and applied as a powder or liquid. Can you evaluate industrial soil conditioners, such as fertilizers and lime? Subsistence farm systems would be less likely to use fertilizers and lime as soil conditioners. The strengths of industrial fertilizers and calcium carbonate or lime would be to replace soil nutrients, to replace the nutrients that have been depleted in the soil, and to increase NPP. The weaknesses would be the possibility of eutrophication due to the runoff carrying excess fertilizer. Also, fertilizers and lime are costly due to the high fossil fuel requirements for manufacturing those molecules. And lastly, they do not increase the water holding capacity because they lack organic matter. So we've looked at industrial fertilizers and lime as soil conditioners to replace nutrients and enhance soil chemistry, mostly for the purposes of increasing net primary production. Now, these soil conservation measures are most likely to be used in industrial farm systems and less likely to be used in subsistence farm systems. The costs of fertilizer and lime are too high for most subsistence farmers. Now let's look at one more soil conditioner, and that is manure. Manure is collected by farmers in less economically developed countries all over the world. Manure is widely available and inexpensive. Manure serves as fuel used to cook food and heat homes, and manure is used to condition soil. Manure as a soil conditioner replaces lost nutrients and provides texture to the soil. The high quantity of organic matter in manure increases the amount of air in the soil as well as the water holding capacity of the soil. Manure adds organic matter to the soil, which ultimately provides soil with nutrients, an energy input. However, it takes time for the organic matter of manure to break down. More than the nutrients that the manure brings to the soil, it's the texture, the water holding capacity, the aeration that makes manure a terrific soil conditioner. In more economically developed countries, manure is used less frequently, but it is used in MEDCs also. Farmers in MEDCs may enhance the soil with mulch. Can you evaluate the use of manure as a soil conditioner? Here are the strengths and weaknesses of manure as a soil conditioner. It's inexpensive. The organic matter adds energy and water holding capacity to the soil, and it increases the biota of soil, which increases decomposition. Weaknesses: it's heavy to transport. The nutrient release is slow. It takes time for the decomposition to happen, and it requires a source of manure. You do have to have manure locally in order to use it. Remember the importance of organic matter in soil. Humus is the black organic substance consisting of partially or wholly decayed vegetable or animal matter that provides nutrients for plants. Loam, the soil that best supports NPP, is composed of sand, silt, and clay in varying proportions, but also loam has humus, decomposed organic matter. In this movie, I've covered terracing, contour plowing, windbreaks, and soil conditioners. And in Part 5, I will examine the cultivation techniques of avoiding the use of marginal lands, some till techniques, cover crops, crop rotation, and reforestation. And that brings us to the end of IBESS Soil and Terrestrial Food Production, Part 4.